Hi friends, hope you all are doing good. Welcome to my channel Code Quest Adventures. So in this video, I will be explaining object-oriented programming principles. So object-oriented programming is a programming paradigm based on the concept of objects which can contain data in the form of fields or attribute and code in the form of procedures or methods. So there are four major principles: abstraction, encapsulation, inheritance, polymorphism. We will go one by one. Just for your info, there are many languages in today's era like Java, C++, Python, C Sharp, Ruby, PHP. All these languages, but these principles. Abstraction. It involves concentrating solely on the essential details relevant to your objective. Abstraction makes things simpler by hiding the extra stuff and showing only what's important in a class or method. Like if I give you a real world example, like when we are driving a car, we don't need to know the internal details or internal mechanism of how the engine works or how the transmission system operates. Instead we just interact with the dashboard, which provides the information relevant to us. So you can say that abstraction is the process of hiding implementation details of a class and showing only the essential features of that object. Let's take an example of a Java code. Here, if you see, I have uh, defined a class, abstract class shape, and it has abstract method draw. And later on, this class circle and rectangle extending that class shape, and they are defining the draw method. But when we are creating the object in the main function, we are we are creating the objects of circle and rectangle classes using the shape class. Thus, I can say that this allow us to treat different objects or different shapes, I can say, uniformly without worrying about their specific implementation. So here we are creating the objects of circle and rectangle using the base class. So this is called abstraction. We don't need to get the details what circle class doing or what rectangle class doing. We can just directly create objects of shape class and just call that draw function. Moving on to the next principle, encapsulation. Encapsulation in Java, it involves bundling data and methods within a class, restricting direct access to data and providing controlled access through methods for improved security and modularity. So you can say that it's a mechanism of wrapping data and code together as a single unit. And if I take a real life example, let's take an example of a smartphone. So it has inner components like memory, sensors. So all these are like encapsulated, like all these is a single unit, in within the device it's there, and we only interact with the outer layer through the interface, such as touch screen or buttons, etc. And it doesn't need direct access as well, because why do I need to know like how's the internal working of touch screen until and unless I need to resolve some issue. So let's take a Java example. Here we have encapsulation example class, which has a variable called private integer age, and two methods we have like get age and set age. So in set age, we are setting the age if it is within a certain range, like from it is greater than 0 and less than 120, else we are just throwing invalid age. And then with the get age function, we are just retrieving that value or that variable. So in the main function, if you see, we need to have this object created for encapsulation example class, and then we can set the data and then retrieve it using the get age function. If we are setting the value out of the range, like it's if it is more than 120, which I have given here as 150, so it is an invalid age. So it will just give that invalid age response message. So yeah, that's about encapsulation. Moving on to the next principle, inheritance. So inheritance, vital in OOP, allows utilizing parents class features and properties in a child class, promoting code reusability. So let's take a real life example. Suppose a kid is there or child is there, he or she will be inheriting certain characteristic of his or her parents. So that's inheritance in real life. Let's take an example of inheritance in Java code. So here we have class called vehicle, which has function drive, which gives out a message. Vehicle is being driven. Later on, a separate class is being created, car, and it's extending vehicle now. So now here, car is a child of vehicle, so it will be deriving certain characteristic of vehicle class. Means it can or it cannot as well. It depends. Same like in real life also, a child will be acquiring certain characteristic based on genes and all. Same like in Java code as well. If we see, we are creating a object for car class, and we are able to like call that drive function using the object of the car class. So this is called inheritance. Moving on to the last principle, which is polymorphism. It's a crucial in OOPS, and it signifies that a class or entity can manifest in various forms, enhancing flexibility and adaptability in programming. Let's take an example in real life. Suppose I have a cycle and I also own a car. And both these objects I can drive, but in other form. So that's polymorphism. I'm able to drive in other way. Let's take a Java example. Here we have a class called animal, and it is defining a function, make sound. Later on, the derived classes, dog and cat, extending that animal class, and they are rewriting the make sound function. Basically, dog is saying woof and dog cat is saying meow. So in this way, polymorphism is defined in this particular Java code. Yeah, so that's about object oriented programming principles. Hope you all like it. Please comment on my channel if you have any doubt. I will be getting back to you. And if you want me to create a video or explain something, do let me know. I will be happy to help you all. Thank you.